Now we're going to take a look at some sealed containers. We're going to show you how we perform our inspection to determine if the seal's been tampered with.
So this is the bolt seal and how it attaches to the container.
That's correct. First thing we're going to do is we're going to look at the probe end, and we're looking at the entire shaft of the probe end, make sure there's no cuts or marring. Next thing we're going to do is we're going to pull down on the locking body. Pull down really hard with a lot of force. We're going to twist from side to side. If you don't get enough leverage with your own hands, you could always use a pair of pliers or a multi-tool. Next thing we want to do is take the locking body and spin it several times in the same direction. Next thing we want to look for is we want to look at the actual locking body. We want to look at the top, we want to look at the sides, and most importantly, we want to look at the bottom. We want to make sure that there's no signs of drilling, cutting, or re-gluing. Next thing we want to check is the actual seal numbers. We want to match them against the manifest numbers. We want to check the margins, front and rear. We want to check the spacing on the numbers, making sure it's uniform, and the alignment of the numbers. If we've seen anything that didn't look right, that's when we pull out our 5 and 10 power scope and we take a closer look at it.
So all this is so you can detect if the seal or container has been tampered with.
That's correct. We're checking the entire probe end, we're checking the locking body, and we're checking the union of both of them. Now let me take you over here and I'll show you some examples. Let's take a look at this seal right here.
Okay, show me how this seal was tampered with.
Remember back to our inspection, the first thing that we check is the probe end. We're going to examine the shaft looking for any signs of cut or marring. We examine the top and the bottom. And right under the head here, we notice a thin line, possibly a crack. So what we're going to do is we're going to grab it and twist it. It really doesn't want to move, so we're going to give ourselves a little bit more leverage by taking a multi-tool and grabbing a hold of the probe end here and holding. Now we're going to twist really hard. When we twist hard, we discover that the top actually threads off. So this seal has been modified so that by unscrewing the head, you can remove the seal from the container without cutting it. So this is a compromised seal. It's an original seal that has been compromised and made to be reattached to the container or removed. Let me show you some other examples we have. Remember back on our test there, after we did our probe end, we examined the shaft on the seal here, top and bottom. We would do our pull test, where we pull back down, we twist back and forth on the seal, and we see when we pull down on this seal with about 30-40 pounds of force, this actually snaps off. The seal was modified ahead of time by grinding off the snap ring landing, so this seal is made to be snapped back on and pulled back off with about 30 pounds of force. That's the reason for the pull test. The next one we're going to show you here is this seal here. Once we do our initial examination of the probe end, the shaft, make sure no cuts, no mars. We're going to do our pull test, pull down, 30-40 pounds of force, twisting side to side. Next we're going to do our spin test. And we see we spin in one direction, it locks up. Once we spin in the opposite direction several times, it actually unthreads. So this seal was modified prior to being placed on a container so that it could be threaded on and threaded off without cutting. Let me show you some other examples. Let me show you this one right here. If we take a look at this seal here, we're going to do an initial inspection of the probe end. We're looking at the shaft, top to bottom, looking for any cuts, any marring. Next, we're going to do a pull test. We're pulling down nice and firmly, twisting back and forth. Next, we do our spin test. We're going to take it, we're going to spin it several times in one direction, several times in the opposite direction. Next, we're going to examine the locking body. We're looking at the entire surface of the locking body. We're looking at the top, the sides, and the bottom. When we look at the bottom, we notice it looks a little bit odd. This is where it pays to have a sample of a known good seal, do a side-by-side comparison. When we compare them side by side, we realize that this here under here is actually a plug. This seal had been attacked through the bottom of the seal, and a plug had been placed in there to cover up the signs of attack. We've seen that this plug here, which is chrome, as compared to a flat bottom on here, so we knew something was different. This seal over here readily shows signs of attack. If you look at the crushed corners over here, that happens when the probe end is pulled and ripped from the locking body. If you compare it side by side to a sample of a known good seal, you'll notice that this probe end is different than this probe end. That's because when the original probe end was ripped out, it was probably damaged and it was replaced with a probe end for another style seal. So this is where it pays to have a side-by-side comparison from a sample of a known good seal. Let me show you another example. We're going to look at some seals here and check the serial numbers. Remember, our first step is to check the manifest to ensure that the seal numbers do match the container. In this case, they do. Our next step is to actually examine the seal itself, and we're looking at the numbers. First thing that we look at is we look at the margins, and we see that the top margin is a lot smaller than the bottom margin. Next, we look at the alignment of the numbers. You see that the number 8 is up from the rest of the numbers. Next, we look at the spacing. You see that the spacing is a little bit irregular. So the next thing we want to look at is the surface that the numbers are actually stamped into. And we see that the surface looks nice and clean. It looks like the adjacent surface. But if we continue looking at the body, and we look at the bottom here, here's where we see all file marks. Okay, this is where the original numbers were. This is an indication that this seal here, the original numbers have been filed off and it's a restamp. So it's very important, if you suspect that a seal is a restamp, that you look at the entire surface of the seal body, because where it was restamped might not necessarily be the same area that the original seal numbers were filed off of. Next, we'll look to our seal at the bottom here. When we look at the margins, we notice that the margin on top is less than the bottom. So the margins are off. The next thing we look at is the alignment of the numbers. We see that the alignment's off. The 5 is a little bit high. Next, we look at the spacing. Spacing is fairly even. So we want to take a closer look. This is where it pays to use a 5-power magnifier. We're going to take out our 5-power magnifier, and we're going to look at the surface of the seals. What we notice is that there's slight file marks going across the surface there, or scratches, if you will. The adjacent surface is more granular. There you can compare side by side and you see the difference. This is an indication that this seal here, the original numbers have been filed off and it's a restamp.
A magnifier is a good example of another tool used to detect evidence of tampering.
It helps you see those small details.
Attention to detail is key in detecting evidence of tampering. It's helpful to have a known good seal for comparison. To perform an inspection of the seal, first visually inspect the surface of the seal, looking closely at the entire probe end and the locking body for any sign of marring. Be sure to look at the bottom of the seal. Pull down on the locking body with 30 to 40 pounds of pressure. Twist the seal from side to side. Use a vice grip or a multi-tool for additional leverage. Turn the locking body several times. If it locks up in one direction, turn it in the opposite direction. Closely examine the serial numbers, looking at the margins, the spacing, and the alignment. Look at the surface for signs that the original numbers have been filed off.
Yeah, so it's not only the seals, but it's also the doors that can be compromised.
Correct. I want to take a look at this door over here. This is a known good set of doors. We're going to use it to explain the nomenclature of the locking hardware, and then we're going to show you the vulnerabilities.
Okay, so it's just like seals that you have to know what a known good door looks like so you can know if it's tampered with.
Right. Let's start with the handle here. This is the hasp here. The hasp attaches the seal to the handle. The hasp is attached by a TIR rivet. The TIR rivet can be cut. Once it is cut, the hasp is swung around with the seal still intact, the handle is lifted, and the door is open. Once the door is open, the remainder of the TIR rivet is removed, a nut is glued in place, the door is closed, the hasp is swung back around, and a threaded TIR rivet is used to try to disguise any evidence of tampering. Moving down the handle here, this rivet here is what actually attaches the handle to the hub, which is welded to the locking bar. Again, this is a rivet. The handle rivet can be cut. Once it is cut, the rivet is removed, the handle drops down, and a bar can be used as a makeshift handle inserted in the hub to open the container door. Then the door is closed, the handle is replaced, and either a threaded rivet or another rivet can be used to secure the handle. Next, we're going to move down the locking bar here to this retaining bracket. This retaining bracket is attached with 4 fasteners, one of which is supposed to be a TIR rivet. In this case, 2 are TIR rivets. But if these fasteners are removed or drilled out, this whole bracket can come off. Once the bracket is off, this bar could be sliced. Once the bar is sliced, it's free from the cam and keeper, which actually secures the door. You can access the container, weld the bar back together again, and replace the bracket over the weld, and that'll hide all your evidence of tampering, and refasten it with threaded rivets on it and bolts. Next, we're going to move right down here to your cam and your keeper. This is your cam, this is your keeper. On the keeper, we want to check to make sure this portion here is not cut off, because if this is cut off, this is what retains the cam. The door can be pushed forward and opened even though the seals are intact. On the cam itself, we want to look at both claws, make sure that they're intact. These claws are cut. Again, the door could be pushed forward, even though the seals are intact. Next, we want to look at how the keeper is fastened to the header. We want to check where the keeper attaches the container, because if it's cut away from the container, the door can be pushed forward and opened, and it would be welded back in place to disguise any evidence of tampering. Next, we're going to move right up the locking bar over here, and we come across the retaining bracket. And this is attached by 2 bolts, has the vulnerability of being able to be cut right across. Next, we come across the retaining flap. The purpose of the retaining flap is to keep the left door from being open, which is not normally sealed, until your right door is open. With a tool, you can bend this flap back, open the left door, and gain access to the container. And Officer Maloney is going to demonstrate that tool. Mo?
It's a simple tool. We take an automobile spring, cut a portion of that away, and we weld it to this steel rod. And what we do is we have a 1/2-inch gap within the 2 pieces of spring as they're welded. And we take this, place it within the flap, apply some pressure, giving us access to open the door. Let me demonstrate this for you. Slide it inside the clip, apply pressure back, just enough to have the door open.
So when doing a door inspection, what evidence is there that the container is breached when compromising the retaining flap?
Well, you look for tool marks, or you look